Hello everyone. Today we are going to deal with the chapter Atomic Structure. Atomic structure is a huge chapter. In that, today we are going to cover a small portion, that is types of bonds. What are the various types of bonds we have? We have electrovalent bond, we have covalent bond, we have coordinate bonds, but coordinate bond is not part of your syllabus. We have only electrovalent bond and covalent bond in the 9th standard. This is there in class 9. So, in electrovalent bond, what are we supposed to learn? First of all, what is electrovalent bond? Which are the elements which take part in this kind of bond? We know there are certain elements called metals and certain elements called non-metals. Which are the elements which are called metals? See, these metals are the ones which have got 1, 2 and 3 electrons in the valence shell. What do I mean by the valence shell? Suppose I talk about sodium. Sodium has atomic number 11. So, according to the electronic configuration, it is 281. So, in the first shell there are 2 electrons. In the second shell there are 8 electrons. And in the last shell there is 1 electron. So, the last shell is known as the valence shell. This is known as the valence shell. And the electron which is present here in the last shell, that is the valence shell, is known as valence electron. So we call this electron as valence electron. Hence, those elements which have got 1, 2 or 3 electrons in the last shell, we call it as metals. And similarly, those elements which have got 5, 6 or 7 electrons in the outermost shell, we call them as non-metals. So one example we can take as, suppose we name any non-metal. Okay, we take chlorine. We all know that chlorine is a non-metal. So what is the atomic structure of chlorine? Can anybody say? Yes. Chlorine, the atomic number is 70. Hence the electronic configuration will be 2, 8, 7. So chlorine in the first shell will have 2 electrons. In the second shell, 8 electrons. And in the last shell, that is the valence shell, please bear with my very bad diagram, I don't draw too well. So this is just a rough sketch to make you understand. In the last shell, we have 7 electrons. 7 electrons. So these are known as the valence electron. Hence, these are called non-metals. So chlorine is considered as non-metal. Now, for electrovalent bond, one metal and one non-metal, they form a bond. When, suppose, sodium tries to form a bond with chlorine, it becomes a compound sodium chloride. In this, sodium's electronic configuration is 281 and chlorine's configuration is 287. So chlorine has 1 electron less in the outermost shell and sodium has 1 electron more. Now why am I saying that it has got 1 electron less and this has got 1 electron more? Why do they need to form a bond? The very first questions come that why do they need to form a bond? They need to form a bond. Why? Because they need to attain a stability. What is that stability? That is, they want to attain a structure closer to the nearest noble gas. Now, if you think of sodium, Which is the nearest noble gas nearer to sodium in the periodic table? Definitely, it is neon. And neon has electronic configuration 2,8. I'm sure you all must be having some source of inspiration. You must be having some people in your life whom you take as your inspiration. So, these metals and non-metals also have got some source of inspiration and they want to attain that particular stability like the nearest noble gases. Even you want to become like a very big star, like you want to become a good cricketer like Sachin, or you want to become a very good actor or actress like anyone, Amitabh Bachchan or anybody else. So everybody has got some role model, even they have got. Just kidding. So sodium want to attain a stable electronic configuration according to the nearest noble gas, that is neon. If I talk about chlorine, who is the nearest noble gas? Here it is argon. Argon's electronic configuration is 2, 8, 8. That is why, if you remember, I said that chlorine has 1 electron less. That means if it attains 1 electron, it will become like argon and the structure will become stable. Similarly, sodium, if you remember, I said, has got 1 electron more. So if sodium releases this 1 electron, it will attain the stable electronic configuration of neon, that is 2, 8. And why, if they attain the electronic configuration of noble gas, they will become stable? You must be knowing that according to the formula, that first shell should have 2 electrons, which is known as the duplet rule, and the second shell should have 3 electrons, that is, second shell should have 8 electrons, that is the octet rule. So according to the octet rule, it will complete its second shell and it will become stable, isn't it? Hence, sodium and chlorine, they bond with each other and they transfer electron. So sodium transfers 1 electron from here to chlorine, and this transfer of electron is known as electrovalent bond. When there is transfer of electron taking place, we call this as electrovalent bond. Now let us take one example. In your syllabus, you will be getting how to draw the orbital structure. Please do learn how to draw the orbital structure. This is there in your syllabus. Orbital structure. If I talk about a compound, say simply first sodium chloride. Sodium chloride. Now, when it is sodium chloride, the structure first I have to draw is Na, 2 electron, then 8 electron, and then 1. And chlorine, similarly, will have 2 electrons, then 8 electrons, and then 7 electrons. So this 1 electron will be transferred from here to here. When this transfer of electron takes place, then sodium loses 1 electron and sodium itself becomes positive. When it loses 1 electron, it becomes positive. Why? Can anybody say why sodium becomes positive when it loses 1 electron? Why we write this plus sign here? This is because we know atomic number is actually number of electrons or number of proton. So number of electron and number of proton both are same. So for sodium, number of electron is 11, even the number of proton is 11. Hence it becomes a neutral atom. But when sodium is losing one electron, then what happens? The number of proton remains the same at the center, that is P equals to 11. So number of proton is the same, but in this case electron is less, one electron less. Hence this plus sign has to be written. This plus sign has to be written. In case of chlorine, this plus sign becomes minus sign. It has got 2 electrons. It has got 8 electrons. And one more shell. It has got 8 electron too, and it attains a negative charge. Why it attains a negative charge? Because it is losing one electron. It is gaining one electron. This one is losing one electron, and this one proton remains 17 only. But one electron is more because there is a transfer of electron. Hence chlorine becomes negative. And finally the compound becomes NaCl. The compound becomes NaCl. I hope I have made myself clear. Now we will proceed with one more example and then proceed with covalent bond. Like this is known as the orbital structure. Now if I talk about magnesium oxide, magnesium has got electronic configuration of magnesium is 2, 8, 2. It has got 2 electrons in the outermost shell. So 2 electrons here, then 8 electrons here, and 2 electrons here. And oxygen similarly has 2 electrons and 6 electrons. So 1 electron from here and 1 electron from here is donated by magnesium, and hence magnesium becomes 2 plus and oxygen becomes 2 minus. Hence the final product is MgO. I hope I am able to make you understand, and you are able to understand the orbital structure. Next we will move on with covalent bond. Covalent bond, what is it? So covalent bond takes place between two non-metals. That is, the electronegativisity difference is very low, which you will learn in detail in class 10. So what happens? Suppose there is carbon atom. It has got 2 electrons and 4 electrons in the outermost shell. And a very important point to be noted is, this is not transfer but sharing of electrons take place. Very important to remember. Hence, in this case, you will see that carbon forms bond with hydrogen sharing one electron. Sharing its electron. So this sharing of electron is known as covalent bond. Now, over here there is no transfer of electron. Hence, we call it as covalent bond. There are various other examples too. Like, example, we can talk about ammonia, we can talk about water. Even it can form bond with its own self, like same element, like two hydrogen atoms existing as a molecule, like one hydrogen here and one hydrogen here, and it is forming H2 molecule. There is one bond. Covalent bond can be of three types. One is single covalent bond, double covalent bond, or triple covalent bond. I'll give you example for each kind. So there is only one bond taking place between the two hydrogen atoms. Hence, we call it as single covalent bond. Now, there is another type like oxygen. Oxygen has 6 electrons in the outermost shell. And 2 electrons here. It is forming bond here. And it is filling up its outermost shell, that is becoming the complete octet. And hence, it is known as a double covalent bond. There is a double bond existing, one here, one here. And hence it is example of double covalent bond. If I talk about a triple bond, that is, you can talk about nitrogen. Nitrogen is a very good example of triple covalent bond. Nitrogen, what is the configuration? It has got 5 electrons in the valence shell. And nitrogen here will also have 5 electrons in the outermost shell. It forms 3 electron bonds. There is sharing of electrons. 3 electrons are being shared here. Hence it is a triple covalent bond. I hope I am able to make things clear. The bonding part, that is the single, double and triple covalent bond. There are other structures like water, carbon tetrachloride, that is the bonding taking place between two non-metals. That is, suppose I talk about carbon tetrachloride. So today we are learning how to draw the orbital structure of all these. So before joining, let me draw it little here. So carbon is having 4 electrons here, and chlorine is having 4 electrons here. And it will form a bond. I'm so sorry, it will be like this. It will form a bond here, and the other electrons are here. Similarly, the other chlorine atoms will also form bonds here. And this one here. So, carbon tetrachloride, one bond here, one bond is here, one bond here, and one bond here. Hence, carbon tetrachloride. It's written as CCl4, or you can write it in the form of bond like this. This is carbon tetrachloride. I hope I am able to make you understand this portion. It can be written as all the bonds are single bonded, so it can be written as carbon and one bond on each side with 4 chlorine atoms, hence tetrachloride. For oxygen atom O2, since this is a double bond, I forgot to mention that there will be a double bond existing between the two. And for nitrogen, it was supposed to be triple bond like this. So there will be a triple bond here in between two nitrogen atoms, hence it becomes N2. And there will be a double bond between oxygen atom, it will become O2. Similarly, over here all the bonds are single, and hence the bond is called all single bonds, hence it is shown with all single lines, and we can write in the form of a formula CCl4. Hence we can say that this is carbon tetrachloride structure. So from now on, please practice this and you will be able to draw the structures yourself, and we will meet very soon in the next class. Thank you so much.